Hello, this lecture will be going over the jig bore assignment that you'll be doing on the mill. This part doesn't really create any big obstacles, if you want to call them that, but we're going to incorporate a couple of new programming features. If I could go over to your jig bore assignment sheet, just want to point out a couple of things on there. You're going to be using the G13. We've done that in the past. Keep note how I'd like you to do this. I want you to do it in 1 Z depth with a smaller step over that 0.05. And then your finish cycle. And 10 thousandths might even be a little bit big. If you're doing about 5, that might be a little bit better for your step over and your radius value. And also I want to point out, make sure you do this with minimal number of tool changes. You want to try to be as productive as you possibly can. The new concepts is going to be where we're going to be using a chamfer. This is very common when you're programming CNC mills. Where we're going to use, there are chamfer tools out there specifically designed for that. But what we're going to be using is just our 3/8 90-degree spot drill. It works just fine. The only disadvantage to using this versus maybe a programmable carbide inserted chamfer tool is your feed rate has to be a little bit slower than what it normally would be. So for RPMs and a feed rate for this, I want you to use the 1500 RPMs and a 5 inches per minute feed rate. The other new concept that we're going to be doing is going to be the G47, where you can initial your name, or I should say engrave your initials or your name on your part. This is used in industry. Maybe not so much for names or initials, but for serial numbering parts. Some manufacturers require that each part have a serial number on it, so it is something you can come across in industry. With the Haas and a lot of your other CNC programming mills, the G47 is a can cycle that can do this. We'll go over that here in a little bit, but once again, for your RPMs and your feed rate, I want you to use 1500 RPMs and a 5 inches per minute for a feed rate. So one thing here that this is, you want to make sure it's visible on your part, and we'll talk about how you want to be able to determine where to put it on your part. So if we go back to our blueprint, just kind of notice that every edge has that 30 thousandths chamfer on it. So all the holes, okay, including the top and the bottom. And then also notice that each corner also has that 30 thousandths chamfer. So that 30 thousandths chamfer, you're going to want to program in no matter where you start when you cut around. Okay? Cut off and then G40. So that'll take care of the chamfer on the corners. To establish this chamfer here, then, what you're going to need to do is run another pass with that 3/8 90-degree spot drill. So the first thing you have to determine is how deep you want to go. So if I could kind of draw my spot drill, that's kind of bad. I'll try to redo that. Okay. So we have a 3/8 body, which is 375. Missed it, 3. So 375, okay? So we have to determine at what point, if I can draw my part in here, do we get a 30 thousandths chamfer, okay? So it's just a matter of doing some simple math, okay? So if I want to say, let's just try to extend this out to here. Okay, so if my end mill was right on that edge, what is my diameter? So for 3/8, and I like to keep it simple math. So I would like to say, let's just say at 0.2 diameter. If I program a 0.2 diameter, if I go 100 thousandths deep, I will just hit that edge with a 90-degree chamfer tool. So with that math, if I want to put a 30 thousandths in there, I just need to drop it down to 130 to go around my part. And in my offset page, I need to have 200 thousandths in for that 3/8 body chamfer tool. Okay. The other way you could do that, let's just say we kept that, let's just say we kept that at 100 thousandths, but then this would have to be remember we'd have to make it smaller, not by 30, we have to double it, so in our offset page we'd have to have 140. So they both work. You just have to kind of determine where that is, what depth you want to go, what your offset needs to be. Now notice this offset is for the 3/8 diameter tool, but that's what you want the program to run it at a certain depth. So they both have to match to establish your 30 thousandths. So once you figure out that, that'll work then for all of these features, and you'll end up with a really nice chamfer. Let's do my print up a little bit here. Okay, so let's say you have the program written complete. Like we normally, you faced off, you did your G13s, you're roughing, you finished, and chamfer, you got this part all done. Typically what we've done now is just flip the part over and face it off and call it good. But our chamfers are also now on the back side. Okay, so you can't just basically throw it back in the mill and call it good. So you're really going to have either a second program or in addition to your first program. You're going to have more features. So the first thing you're going to have to do is determine how to pick up your X and Y zero, because you're going to be running your chamfer tool all the way around that outside, just like you did. You're not going to run around with your carbide or your rougher, but you're going to run around your chamfer tool to get your chamfer on that outside, along with on the bottom of each one of these holes. Okay, so you're going to have you have to pick up your edge find. The best way to do it, you should have programmed everything off of 0, 0 here. The best thing would be basically just tram that center circle and call that 0, 0. You do want to make sure you get the part in there orientated correctly. Otherwise things won't go so well with your chamfer tool when you hit your holes. So like I said, it's basically going to be 2 programs. You can write it as one, but it might be just as easy to do 2 programs, and watch your orientation when you flip your part. So that'll create a new challenge for you. So if you have any questions, please come and see me. Otherwise, good luck.